So we'll start with relay. Can anyone tell what is relay?
Relay like a switching device.
Okay, why it is used?
Means protection purpose, say PLC.
Okay, for protection purpose it is used.
Yes, ma'am.
Okay, fine, correct. So now relay is an electrical device which is activated by a current or a signal in one circuit to open or close another circuit. Okay, it's a switching device. It's an electromechanical switch. Okay, it is a combination of mechanical and electrical circuit. So used to turn on or off a circuit with a low power consumption. Okay, it is like using a low power consumption, you can activate a high power elements. Okay, so automation can be achieved by using it. Okay, it is one of the advantage, and it is used for long distance switching. Okay, whenever we used very long wires, there will be chances of wire breaking or delay will be there. Instead of that, for every particular distance, the relays will be used. Therefore, it will be acting like a repeater. Okay, it will be used as a repeater. Okay, there are four terminals in the relay. One is the power supply. Next, normally open, normally close, and a common contact. Okay, in this one, the normally open and normally closed is a fixed type contact. Okay, and common contact is a movable contact. So, based on this movable contact, whether it is moved towards NC or NO, we will be telling whether it is a NC contact or a NO contact. Based on this logic, the ladder diagram is designed. Okay, first before ladder diagram came into picture, it was relay diagrams. Okay, based on the combination of NC and NOs, the program they used to design the program. Later on, they came up with the ladder diagram program. There also we'll use till now we'll be using this NO and NC terminologies. Okay, and the operation is almost similar. So now this is the internal structure of a relay. Okay, so you will be having a magnetic coil, and this coil is supplied with the power supply. So this here we'll be giving a voltage supply. It will be 24 volt or 12 volt or 5 volt we'll be giving. Okay, based on the flux induced. So based on the flux induced, there this armature will be moving. Based on this movement, this movable contact, which is nothing but a common contact, this will have a contact between either normally open switch or a normally closed switch. Okay, now this is the input side of the circuit. Okay, so here at this side, either for NC or NO, we'll be connecting our lamp, motors, valves. Okay, based on our requirement or based on the outputs, we'll be connecting either it to NC or a NO connection. Now the other next is the classification of relays. Okay, so relays can be classified based on number of poles. Okay, that is nothing but number of commons, and based on number of types. Okay, that we'll call it as poles and throws. For common, we'll call it as pole, and for contact, we'll call it as throw. Okay, so now if we have a single pole, single throw, that means if we have a single common and a single contact, then it is called SPST. If we have a single pole, that is single common and a double throw, then it will be SPDT, then DPST, DPDT. This is double pole, single throw, double pole, double throw. Okay, these are four different combinations. The relays are classified. Okay, so the most commonly used is double pole, double throw. Okay. Now here you can see the single pole, single throw contact can be classified into two categories. One is NC or a NO. Okay. This NO connection, single pole, single throw NO connection will act like a switch. Okay. And single pole, single throw, it will act like a NOT gate. Okay. The SPST will act like a buffer, and SPST NC will act like a NOT gate buffer or a voltage follower, we can say in other terms. This will be a NOT gate. Okay. Now here you can see um, there is small gap between common terminal and a end NO terminal. Okay, this is NO, this is common. Okay, now whenever the voltage is applied across this magnetic coil, flux will be induced. Okay, once the flux is induced, the armature will start making this movable contact to move. So that time, this contact based on the voltage level, it will get connected to this normally open. Okay. So then will giving a output voltage. So when you apply the voltage, the flux will be induced and it will make the common will be moved. Okay. This is about NO operation. Now in NC operation, what happens is that it will be initially connected. Okay. Initially itself, it will be connected to NC. You can see here, there is no gap. Okay. So it will be connected and the whatever output we connect. So we'll be getting an output here, this side. Now, when I apply voltage here, this will break the contact. Okay. Making the output element off. This is of NC connection. So this is of the relay working. So here you can see they have shown clearly. You can see here. This is a NO connection. Okay. You can see here this bulb is connected to NO terminal and the common terminal. Imagine this is the output socket and common is given to the source. Okay. Common has to be given with the voltage source. Okay. Now, whenever we apply the source, this common will start moving and it will have a contact with this NO pin. Once it gets contact here, the current will flow through the bulb. Okay. So when light turn on when relay is made on. So this is NO connection. Okay. Now here you can see. Here see, the lamp is connected to NC connection and the common is already connected to NC. So therefore, the current will flow through the bulb. Okay. But when I apply the voltage, this will move. Okay. And de-energizing the bulb. That time, no current flows. So this is NC connection. Okay. So to remember this, we can imagine that this is not gate, and this we can imagine as a buffer. Okay. Okay. So based on this, we have NC and NO connection in a ladder diagram. So this is all about relay. Now, we'll see the which are the components we'll be using in the ladder diagram. First is input contact, output contact. Then there will be interlocking. There will be memory coils, latching, timers, counters, comparators, arithmetic operations. You'll be having PID controllers. Okay, so there are so many functional blocks we'll be using in the programming. Okay, out of which input and output contacts are really, really important. Okay. So now this is how NC-NO contacts look. Okay. This is a NO connection. This is NC connection and this is the output coil. Okay. So I'll share this PPT as well. So don't forget these symbols. Okay. These are really important. Okay. This is how we'll indicate NC and NO connections. Now to write the ladder diagram, we'll use rungs and rails. Okay. Now, the horizontal lines are called rungs. Okay. And the vertical lines are called rails. Okay. It is ladder diagram because the program structure looks like a ladder. So it is named as a after the ladder logic. Okay. So here the 5-volt will be running. This is a 5-volt line and this is a ground line or
Zero.
a 0-volt line. So the current will be flowing, okay, like this across the rungs. Okay, so we'll be connecting switches or like in the NCNO contacts, output coils, timers, counters, motors, whatever we had. think of it, we'll be connecting in the rungs, either in series connection or in parallel connection. Okay. So if I take this combination, so this will be, I can imagine switch 1, switch 2, and this will be out. Okay. This is one simple combination where we'll be using NO, NC, and a output coil. Okay. This is how we'll write the ladder diagram. Okay. And no confusion? That's good. Now, whenever we write ladder diagram, it is very important to know the few rules of writing the ladder diagram. Okay. If you not follow that rules, you can't create a ladder diagram. It will be showing some or the other errors. Okay. So now let's see what are the rules of ladder diagram. So there are 4 rules. We have to be very careful. So the first rule states that input should be placed on the left side and the output should be placed on the right side of the rung. Okay. Whenever we write the ladder diagram, always the input should be placed. Either it might be NC, NO, whether you connect it in parallel or series, whatever. It should be always there in the left side. You cannot place a switch in the right hand side. This right hand side is always dedicated to outputs. Okay. You should make sure that, and some software will not allow you to place the coils in the left hand side. Okay. The software itself will be taking care of this first rule. Okay. The second rule states that input can be placed in both series and parallel, but output can be placed only in parallel connection. So now if I connect 2 switch in this connection, it is called series connection. Okay. And if I connect 2 switches in this format, it is parallel connection. Okay. But I connect a switch and I cannot connect output like this because I have mentioned some other one condition to this output and the other condition to this output. Now, when I connect like this, let's say the current flows from here to here, and from here to here, and from here to here. Now, until unless this condition won't go true, this won't be on. But according to my program condition, this has to be on for the given condition. But this is in the off state. Okay. Until unless this won't get on, this cannot be made on. Therefore, we cannot connect the output coil in series connection. Okay. There we have to always connect the switches in parallel connection. Okay. Understood? Any confusions?
No, ma'am.
Okay.
Output and connect parallel में.
Yes, output has to be connected in parallel connection only.
Okay.
Okay. So input can be repeated n number of times, but output cannot be repeated. Okay. So here input repeated means the input addresses. Okay. So every in the input card, every input terminal is given with a specific address. Okay. I can repeat that specific address anywhere in my program. Let's consider I0.0. So in my whole program, I can repeat the input address I0.0, but I cannot repeat the output address. Okay, I have to use different output address. If I repeat the output address, the processor will get confused. Okay, so it will be fluctuating between these two conditions. Hence, we can repeat the input address, but we cannot repeat the output address. Okay, understood?
Yes, ma'am.
Okay, now the fourth condition is saying that output can be repeated, but in input side, but output address cannot be repeated. I can repeat this address, whatever this coil is storing, I can use that memory condition in the input side. Okay, I can mention the output address at the input side, but I cannot mention the input address. Okay, so it will not take mentioning the input address. So I have to use only output addresses at the output side. Understood?
Ma'am, if we use input as output, while compiling, it will show, right?
Yeah, while compiling, it will show the error. So you see,
Yes.
in this 4 rules, whatever you do the mistake, it will show. See, for the first condition, few software won't allow the placing of the coils at the input side. Okay, whereas the place series connection also, the compiler will be showing the error. Even the address repetition, that will also, yeah, it will be showing the output is repeated during the compilation. All these 4 rules, whatever it is there, if any one rule is not satisfied, either the compiler will show the error, or while creating the program itself, the software won't support the combination. Now, Mallikarjun and Srinivas, you know the basic gate, right? Don't answer any questions. Rest, please answer. Okay.
Okay.
So can anyone tell how many basic gates are there?
AND gate, OR gate, NOT
Total
gate,
7
NOR
gate,
gate.
madam.
Okay. Someone was naming them. Then,
Or
OR gate,
okay. Then,
NAND,
XOR,
NAND,
NOR,
NOR,
XNOR,
XOR,
XOR, and XNOR.
XNOR.
Okay. Which are the universal gates in this one?
No. NAND, XOR, no, not.
Universal gates. NAND is correct. Only 2 universal gates are there. Which are the universal gates?
NAND gate, XNOR gate.
Hmm?
NAND and XNOR.
No. NAND and NOR are universal gates. Okay.
Yes, madam. Okay, madam.
So these 2 are universal gates. Okay. Now, can anyone tell me what is the operation of NOT gate? What does it do? If I give 1 here, what will be the output?
Output is 0.
0, ma'am.
0.
Okay. So this is NOT gate. In ladder diagram, using which combination I can realize the NOT gate? Just now I explained, no, 2 switches NC and NO. So which switch I can use?
NO
Mallikarjun.
switch, ma'am.
NO switch.
NO means 1, NC means 0.
No, not NO means 1, NC means 0. It is a switch, right? When you give 1, what happens? When you give 0, what happens? You have to tell like that. Not 0 and 1.
NC means opposite.
Opposite.
NC come to NO and then come to the NC.
What
Opposite.
happens to NC? Like what happens to NC switch when I give 1? What will be the output?
Output 0. Whenever NC will come, then NO output. Then NO will give, NC will output.
What? Come, say it, repeat it again. I didn't get you.
Actually, NC switch, then we will get output NO means 1.
Okay. NC switch, then it will get N1, that is 1. If I give 1, if I give high signal, let's
Then
say if I give high,
we
or
will
if I give 5 volt,
yes, ma'am.
what I'll get? If I give 5 volt, what will be the output?
Output 0.
Okay. If I give high condition, high state, output will be?
Then 5 volt will come.
If you give high, it will give 5 volt.
Then 0 we will get output.
We'll get low state. Okay. If I give 1, what I will get?
Low.
You will get 0. Okay. Don't tell if I give 1 to NC switch, it will give a NO output. Don't tell like that. Okay. So here the NOT gate will act like a NC switch. It is a single input gate. Okay. So we'll use a NC contact. Whenever we want to use a NOT gate, we'll go for NC contact. Okay. So now, how many inputs we can use for NOT AND gate?
It's 2, madam.
Maximum 2, minimum is how much?
Madam, actually 2 inputs, madam. Maximum, minimum, not there.
No,
madam.
you can connect. There are 3 input NAND gates, 4 input NAND gates. Okay, you can connect n number of inputs, but you will be having only 1 output. Okay. So what operation does AND gate performs?
Both are inputs high, madam. Output will be high, madam.
Okay. So if both are A into B. Okay. Both are high, output will be next. Can anyone tell about OR gate?
If any inputs A or B high, then we will get
One
high.
input is a out.
Okay. So it will be addition operation. This is multiplication operation. Any one input is high, output will be
High.
high. Okay. Next, what about NAND gate? Can anyone tell me why it is called universal gate? Why these two are called universal gates? Why it is called universal gates?
NAND gate is inversely proportional to AND gate, madam.
That is okay. Why it is called universal gate? Why it is called universal gates?
I think we can use AND gate like NAND gate.
Huh?
We
I
can
didn't get
use
you.
NAND gate like AND gate.
Like you can use NAND gate to get what?
Ma'am, it is combination of basic gate that is not and AND, so that's why it is called a universal gate.
No, that's not the answer. It is universal gate. They are called universal gate. Why? Because you can realize all the basic gates, NOT, AND, OR, XOR, XNOR, NAND, NOR, using NAND or NOT gates. Hence, it is called universal gates. But using AND or XOR, XNOR, you cannot realize all the 7 gates. Okay. Hence, it is called universal gate. So, can anyone tell me the operation? What will be the output condition? What happens if both inputs high? Any one input is high? Are you
NAND
people
gate
there?
is both input is high, madam. NAND gate both input high is there, mean output is 0, madam. NAND.
I didn't get you.
NAND gate is any one input is high, output will be high, madam. NAND.
Any one input is high, the output will be high, then it is OR gate, no? If any one input is high, output is high is OR gate.
Actually,
In NAND gate,
AND gate,
both the inputs are low, output is high.
Both the inputs are low, output is high. No,
Madam, any one input is different, madam. Output is high, madam.
any one input is different, output is high. What is the different condition, high or low?
Madam,
There are 2 conditions will be same, no. Input the 0, 0 and 1, 1 conditions are repeated, no. Then what is different?
in NAND gate we program.
Everyone write the truth table, then answer the question. Write the truth table of NAND gate and send me the pictures. If you guys won't do the homework, we'll do the homework in the class, okay? Everyone write the NAND gate truth table.
And opposite of NAND result, what we will get in AND, that is
Opposite of NAND is AND. Okay, that result will get. You tell it in simple words. Whether it is both are high, output is high, anyone is high, output is high, like that. Your answer is correct. The
Okay, ma'am.
complement. Huh. Did you guys write it? Share me in the group. I want to see everyone's output, like truth table. It is just a simple truth table. Why are you people taking such a long time? Don't Google it out. How much ever you know, just write it and send it. Mahantesh wrong. No, correct. Sorry. Yeah, now, what about others? Sorry, Mahantesh, it's correct.
Okay, madam.
Sushant, there is one more condition. 0, 1. What about that? You have written only 3 conditions. Okay. Gopi, it's correct. Now, Radhakrishna, you have to tell me the NOR gate condition as well. So you should first answer it. Okay.
Not gate or NOR gate?
NOR gate.
NOR gate. Okay.
Mahantesh, it's correct. Gavi, where is your answer? Are you there? Okay, fine. We'll continue. So after writing the truth table, how can you define it? Whether you consider high condition or a low condition.
High condition.
Okay, if you take high condition, what you will tell? So if both the inputs are high, then output will be? Inputs are high, output will be?
Output also high.
Output will be low. If both the inputs are high, output is high means then it will be AND gate, no?
Acha.
Okay, now what about NOR gate? Both the inputs are high. Whether you consider both the inputs or any. Okay, fine. Got it, Kavi Siddhappa. Okay, what about NOR gate? Please answer it first. Radhakrishna, it's your turn.
NOR gate quite opposite over OR gate, man. Say.
Yeah, that is okay. Quite opposite to OR gate. If you can add a NOT gate. Okay. If any one of the input are low, what about the output? Sushanta, it's correct. Radhakrishna, please answer the question. You have made everything 0. What is the use of using this NOR gate?
I don't, madam. I don't know.
You don't know. Okay, see, if both the inputs are low, then only output will be
High.
high. Okay. So here also we have to consider low condition only. If any one input is high, okay, output should be
Low.
high, not low, high. Okay. So now please tell about XOR and XNOR gates. This XOR and XNOR gates will follow a typical binary logic. Okay. Yeah, Mahantesh, it's correct. You guys have done, you could have done your homework. No, I need not to waste my time like this. Okay. So now XOR and XNOR gate typically follows the binary addition. Okay. That is, whenever we add whenever whenever we add ones, okay, 1 plus 1, it is not 1, okay, it is actually 0 and 1, okay. So this XOR gate this is a carryover, okay, it will give 0 and 1 will be carry forward. So this is carry and this is the sum. So it will discard this carry, okay, therefore retaining only 0. But in the AND gate, whenever we are using OR gate, it will directly consider it as 1. It will not have this condition. It will not do the addition like this. Okay. This is a typical binary addition because in binary we have only 2 terms, 1 and 0. Okay. When we add 1 plus 1, it should be 2, right? But in binary, it is 1, 0. Okay? Understood? We should know that in binary, there are only two numbers. One is 0, another one is 1. Okay? So let's perform an addition of 1 plus 1. So in decimal format, 1 plus 1 is nothing but 2, right? Correct?
Yes, ma'am.
Now, whenever we do the addition of binaries, okay, let's consider 0 plus 0. It will be 0, okay? 0 plus 1, it will be 1, okay? But when we perform the addition of 1 plus 1, it will add, okay? So 1 plus 1 is 2 in decimal, but in binary it is 0 and 1 is carry forward, okay? So therefore, it is 1, 0. This is 2 power 0, this is 2 power 1. So it is nothing but 2 into 1 plus 2 into 0. It is okay. So therefore, we'll be getting, sorry, not plus. So we'll be getting 2.
2.
Understood?
Yes, ma'am.
So when 0 plus 0 is 0, correct? 0 plus 1 is how much?
1.
1 plus 0? 1 plus 1. Whether should I write 1 or 0?
0.
0, madam.
So this is the exclusive OR gate, okay? So now XNOR is nothing but the complement of XOR gate, okay? Understood? Any confusion?
No.
Any confusions? So please share me the XNOR truth table. And there is one more thing I need to tell you. Whenever you have two inputs, okay, whenever you have two inputs to gates, so the truth table, the output combination will be n power, not n power, 2 power n, okay? This 2 power n minus 1 combinations will be there, okay? Understood? Sorry, 2 power n combinations will be there, where n is the number of inputs. Okay, here I have taken two inputs. So 2 power 2 will be 4. Therefore, I have 4 combinations. Okay, so these are different 4 combinations. This is 0, this is 1, this is 2, this is 3. This is how we represent it in binary. Okay. So this is 0, 1, 2, 3. Okay. If I have a 3 input gate, then it will be 2 power 3 and I will be having 8 combinations. Okay. Understood?
Yes, ma'am.
Did you people share XNOR truth table? Anyone? Everyone, please share it.
Shared, madam.
You guys understood?
Yeah.
Yes, madam.
Any confusions in basic gates?
No, ma'am. No, nothing.
See, whenever you write the ladder diagram, basic gates are really important, okay? This and or operations and all. So whenever you're not able to solve any combination, a programmer has asked you, like given to you, using this basic gates, you can make it easier, okay? So whenever we write the ladder diagram, whenever there is whenever we are using multiple switch and output combinations, we'll first write the truth table, okay? We'll write the truth table, then we'll implement it in the ladder diagram. That's why I gave so much time for basic gates, okay? So this is very important. Whatever multiple switch and lamp combination, if they have asked you, or sensor combination, if they ask you, so try to imagine it in terms of binary gates. It might be and or operations. So it will be easier to you to write the ladder diagram.